Hello, in this video we are going to create the graph of a rational function, and we're also going to find all of the asymptotes. We're going to do this with the help of our graphing calculator. Here in my graphing calculator I'm going to type the function in my y equals. I'm making sure to group the numerator and the denominator. So my numerator is x plus 2. And then I divide and again use parentheses to group the denominator where we had x squared minus 4x minus 12. With rational functions, I typically start by using the zoom button, and I use option 6, the standard, and that shows me two pieces, and so that looks like my graph. It definitely appears that I have a pole right in here, so that's 1, 2, 3, 4, 5, 6 at positive 6. And as I look at the left, it definitely appears to be very close to 0, and the right appears to do the same thing. So let's put that all together. We used a graph that was 10 by 10. So our x, there we go, went from positive 10 to negative 10. And our y did the same. And we saw this piece of the graph come very close to 0 and then curve down. And we saw this piece of the graph curve down very close to 0. So in between these two, we observed our vertical asymptote or pole. Vertical asymptote or pole. And we thought it looked like it was at 6. So we think the equation x equals 6. And then in this direction, and let me get a different color pen here so we can see this, we thought it looked like the graph was approaching 0. So we felt like right here was the limiting value. Both sides of the graph did the same thing. So our horizontal asymptote or limiting value appeared to be at y equals 0. So let's take a look at our equation and see if this stuff matches up. So we know for the vertical asymptotes that they occur at the zeros of the denominator. So in order to find zeros for this, I'm going to try to factor this denominator. So that means I'm looking for factors of negative 12 that add up to negative 4. So I can split up my x. I can split up 12 to be negative 6 and positive 2. They'll multiply for negative 12. They'll add to negative 4. So then I put x plus 2 equal to 0, and I get x equals negative 2. And I put x plus 6 equal to 0, and I get x equals negative 6. Excuse me, positive. Wow, messed up my signs there. In my original problem here, I had a minus, and when I solve that out, I get a plus. Now, when we looked at the graph, we saw this asymptote. So we have this pole. But when we looked at the graph, we did not see this one. And the reason why we do not see it is because when we factor, this 0 that we saw in the denominator matches the 0 of the numerator, because these factors match. And although we're not asked to simplify the fraction, truly this is a common factor from numerator to denominator, and that factor of x plus 2 cancels. So because that factor cancels, that does not show up here on the graph as an asymptote. Right? So we do not include this in our list of all the asymptotes because this one is canceled out by the 0 of the numerator. And then to double check our horizontal asymptote, we're supposed to look at the degree. So the degree of the numerator is 1, the degree of the denominator is 2, and that means that this is less than, because 1 is less than 2. When we look that up on our chart, the meaning of that is that the asymptote is at y equals 0, and that does double check with what we found here, and then we observe that it is at y equals 0.